In this video, we are going to study destructuring. The idea of destructuring is to make it easier to get values from an object or an array and put them into variables. Let's see an example. Here we have this person object, and as you can see, it has these properties: first name, last name, age, and current date. Let's say that I want to get in a variable these three properties: first name, last name, and age. For that, I can do the following. I can say const first name equal to person dot first name, then const last name equal to person last name, and finally const age equal to person age. That is fine in general, but we can abbreviate this. Instead of doing this, I can comment this out and use destructuring. For that, I have to do the following. I will say const, and then I will open curly brackets. And in here, I will say first name, last name, and age, and this is equal to person. And that's actually it. With this, we have destructured our object into these three variables that we have here. What this is doing, this is just a shorthand. This is a shorthand for all of this that we did here. We are saying that first name is going to be a constant that will be equal to person.firstname, the same for last name, and the same for age. I can prove that to you. I can say console log, and I will just say first name, and I want to go to the terminal, new terminal, node destructuring, enter, and as you can see, we have Felipe here, which is this variable that I have here, which means that indeed we use destructuring to decompose our person object into these three variables that we have here. Now, of course, notice that these variables have the same name as the properties of the object. For example, first name and first name. I cannot say first name 2, for example, because then this will be undefined. Let me say first name 2 here, and let me save. Node destructuring, enter, and as you can see, we have undefined here. So we have to use the exact same property name in the variable that we're putting the value of that property. And this is really cool because we can also use it, for example, and let me hide this terminal by using Ctrl+T in Windows. This is really cool because something that we do is to use it with a value that is returned by a function. For example, let's say get address, and I will say here arrow function return an object, and I will say street 1, country 1, and state 1. Now let's say that I want to get a street and country from this function. How can we do that? Well, we can say const street and country equal to get address. And that's it. With this, street is equal to street 1 and country is equal to country 1. Something else that we can do is to destructure the parameter of a function. For example, let's come down here and I will say print name equal to person. This is the parameter, and here is the body of the function, and I will say console log person.firstname. So what I'm doing here is that I am receiving a person and printing his first name. Now, what if I don't want to do this? What if I don't want to have to say person.firstname? What if I just want to destructure this parameter and put this first name property in a variable as a parameter of the function? We can do that. Let me say here print name2 equal to, and here I will say curly brackets, and I will say first name, and then I can do the following. I can say console log just first name, and in this way, whatever the object I pass into this print name2 function, we're going to extract its first name property. We're going to put it here in this variable, and then we will be able to use it. Let's see an example. Let me say print name 2, and I will pass our person, and you are going to see that we will get my first name printed in the console. So let me say control backtick, and let's say here node destructuring, enter, and as you can see we have my name here, which is great. Until now we have used destructuring only for objects, but we can definitely use them for arrays. For example, let me comment this out and let's come down here, and I will say array 1, 2, 3, 4. Let me put it in a variable const array equal to this. Now I can do the following. Let's say that I only want the first, second, and fourth value of this array, and I want to put them in variables. For that I can say const square brackets first, second, comma, comma, fourth equal to r. And that's actually it. With this, what I'm saying is that I want the first value of the array to be here, the second value to be here, and since I am using 2 commas, it means that I am stepping over the third value and going directly into the fourth value. So fourth will be equal to 4. And I can prove that to you. I can say console log, let's say second for example, and I can save. I can go back to the terminal, node destructuring, and here as you can see we have 2 because this variable that we have here is equal to 2. In this video we are going to talk about the spread operator. With the help of the spread operator we can extract the values of an array or of an object, and then we can do whatever we want with those values. Let's see an example of that. Let's say example 1 here, because we're going to see about 8 examples today, so I will separate them with comments. So let me say something like sum equal to a plus b. Let's say that we have this function sum, which sums these 2 parameters. And let's say we have an array of numbers equal to 2 and 3. So this is an array of 2 values, 2 and 3. Now, I want to say console log sum numbers. So I want to sum these 2 numbers using this sum function. But this function receives 2 parameters. But here I am only sending the array. What I want to do is to send these 2 values individually. One way of doing this would be to say 0 and numbers 1. So in this way, I am sending the 2 and the 3. But there is a better way of doing this, and that is with the spread operator. With the spread operator, we will be able to extract these values from here and send them as parameters to this function. So let's do that. Let me delete this and let me just say dot dot dot. And that's actually it. With this we are extracting the values of this array. Let's see that. Let's go to the terminal, new terminal, and I will say here node spread, tab, enter, and as you can see we have 5 here, which means that indeed we sent 2 and 3 into this sum function. What else can we do with the spread operator? We can concatenate arrays with it. For example, let's say example 2, and I will say const more numbers equal to 1 and numbers. But look at what we're doing. I am saying that this array more numbers will be equal to 1, 2, and 3. This is different than saying const more numbers 2 equal to 1 numbers. There is a big difference between these 2. This one is 1, 2, and 3, but this one is 1 array 2 and 3. This one have an array of 3 elements, and this one is an array of 2 elements. The first element is a number and the second element is another array. So again, they are really different. Here we are concatenating the values of the arrays. And we can also do the following. We can say const more numbers 3 equal to 1 numbers with the spread operator, and 4 and 5. So the value of this array more number 3 is 1, 2, 3, 4, 5. We have concatenated the 1, the values of the numbers array, and then 4 and 5. As you can see, it is really easy to concatenate arrays by using the spread operator. Of course, we can concatenate arrays in this way. Let's say example 3. I can say other numbers equal to 4 and 5, and I can say const concatenated arrays equal to a spread operator of numbers and a spread operator of other numbers, and this will be equal to 2 and 3 and 4 and 5. Something else that we can do is to combine destructuring with the spread operator. For example, what if we want, let's say this array for example, what if we want to have this first element in a variable and the rest of the array in another variable? We can do that. Let's say example 4, and let me close this and let me put a column here, and I will say const first. Look that we are doing a destructuring, which is why we are declaring this variable using a square bracket. And after that, we're going to say the remaining values. As its name implies, this array will have the remaining values of our array. So let's say concatenated arrays, and now let's console log this, because first is going to be equal to 2, and console log the remaining values, which will be an array with the values 3, 4, and 5. Let's see that. Let me comment this out so that we don't have any other values in the terminal. I will open the terminal and I will repeat node spread operator, enter, and as you can see we have 2, which is this value, and 3, 4, 5, which is the remaining values array. So this is indeed working. Something else that we do with the spread operator is to clone things. For example, we can clone an array. As you know, an array is a reference value, which means that when we store an array in a variable, we are not storing the value itself, but a reference to the value. So if you want to be able to have two versions of the array and modify one and not modify the other, you can clone it. For example, I can say const concatenated arrays clone, and I can clone in this way. I can say concatenated arrays. And that's actually it. With this we have two versions of the same array, and they are independent from each other. Now let's talk about the spread operator but with objects. Let's now use the spread operator for objects. Let's make the following example. Let's say that we have two objects and I want to combine them. I want to say const person equal to name Felipe and also last name, let's say Gavilan, and now I will have another object const person 2, and let's say that here I have age 999. This is fine, and let me put an equal sign here, which is great. Now what I want to do is to combine these two objects. I want to insert these properties into this person2 object. One way of doing this would be to say name equal to person.name. That will be fine, but there is a more effective way of doing this, and that is by using the spread operator. With the spread operator, we can get the properties of the object and put them here. Let's do that. I'll just have to say ... person, comma, and that's it. Let me say console log person2, and let me comment out whatever other console log we have from the past. And now let's come here and I will say node spread operator, and as you can see we have an object which has the properties name, last name, and age, which means that indeed we combine the person and person2 object. Something else that we can do, just like we did with arrays, is to clone an object. Let me say example 7, and here I will say const person3 equal to ... person2, And in this way, I am cloning the person2 object, which means that this person3 have the same values as person2, but it is a different instance. Therefore, they are independent from each other. For example, let me give you an example just in case this is not clear. I will delete this. Let me do the following. I will delete this. I will not use the spread operator, which means that these two objects reference the same instance. If I say person3 dot name equal to Scott, now I will do a console log person2 and person3. And let me comment this out. And let's see what we got. Let's come here, node spread. And as you can see, both of them has the name Scott. Why is that? That is because an object is a reference value in JavaScript, which means that when I say person3 equal to person2, it means that now both variables are referencing the same instance of the object. So when I say person3.name equal to Scott, I am changing the underlying object which this variable is referencing, which is the same object that this other variable is also referencing. Therefore, a change in one will be the same as a change in the other. That is why we have to rely on cloning the object, for example using the spread operator, so that we don't have that problem. Now I can save and I can come back here and I can say node spread operator, enter, and as you can see, person2 retains the name Felipe, meanwhile person3 has the new value Scott, because we cloned the object, which makes a new instance of the object. Something else that we can do is that we can combine the spread operator and the structuring for objects. Let's see an example. Let's say const the structure age, comma, person4 equal to, and let's say person3. Now, what am I doing here? As you know, we are using destructuring to destructure this object into its different parts. So I am extracting person.age into this age variable, and the rest of the other properties are being put into this person4 variable, which basically means that age is going to be equal to 999, as you can see here, and person4 will be the rest of the properties of the object, which are name and last name. Let's see that. Let's say console log age and console log person4. Let me comment this out, and now let's go back to the console and let's say node spread operator. I'll press enter, and as you can see, we have here that age is equal to 999. Meanwhile, person4 is equal to name and last name. In JavaScript, we can create classes. You can think of classes like blueprints, which will allow you to have different objects with the same structure. The idea of the class is that in it you can define functions and data which then objects created from the class can use. This allows you to have different objects which are guaranteed to have the same structure. Let's see an example of a class. I will say here class rectangle. This class is going to represent a rectangle, and something that we can define in a class is a constructor. I will say constructor, and in a constructor we can define the initial values of the object that you are creating from this class. For example, a rectangle should have height and width. So I am putting those here in the constructor. Basically, the constructor is a function that will be run once the object is instantiated from this class. So I will say this dot height equal to height and this dot width equal to width. What is this? What did I just do? With this syntax, this dot height, I am saying that height is going to be a property of the class and also width, which means that once I instantiate an object from this class, I will be able to access the height and width properties. Let's see an example of this. In order to instantiate an object from a class, we have to do the following. I have to say something like const rectangle1 equal to new rectangle, and as you can see here, in order to instantiate an object from a class, we use new and then the name of the class. And in here, in these parentheses, we have to pass the parameters of the constructor. So I will say something like 7 and 2, for example. And now I can say console log rectangle1 dot. And as you can see, we have height and width. For example, let me say height. And I can console log that. Let me open the terminal, new terminal. And I will say node classes, enter. And as you can see, we have 7. What would happen if I delete this? Let me just comment this out. Let me save, and now let's come here, and let me press enter, and as you can see we have undefined. Why is this? Well, because since we are not doing this dot height, then it means that we are not declaring height as a property of the class, and therefore we cannot access it through the object that we instantiated from the class. So let me put this back as it was, and let's continue. As I said before, besides defining data, I am defining data here as properties. We can also define functionality for our classes. For example, let's say that I want to have a function here, which is going to be called area. And this area function is going to allow me to calculate the area of this rectangle. So let me say console log the area of the rectangle is, and I will say here string interpolation, and I will say this dot height times this dot width. And now I can go to the rectangle1 object and say rectangle1 dot area. And let me comment this out, and let's just focus on this one, and I will come back here, node classes, enter, and as you can see we have the area of the rectangle is 14. Now if I clone this line and say rectangle2 and say for example 5 and 3, I can do the exact same. I don't have to define the area function for this rectangle 2. No, I can just use the area function that we define in the blueprint in the class. So I can say here rectangle2.area, and I can just say node classes, and as you can see we have the exact same functionality but with different values, which means that one of the advantages of using classes is to be able to reuse code. As you can see, we are reusing the same functionality in rectangle 1 and rectangle 2. Though I am able to override the area function at the level of an object. For example, rectangle 2 is an object, right? So I will say here rectangle2.area equals to, and I will define a function here. So what I am doing is that I am overriding the area function, but only for this rectangle, not for this one, only for this one. I can say, for example, console log new implementation, and I can save, and I can come back here. I can delete all of this just to have more space, and let's say node classes, and as you can see we have this area which was invoked, which prints the value, the area of the rectangle is 14, and then we have this other rectangle here, and we are overriding the area function, and that is why we have here new implementation, which is this message that we have here. Speaking of reusing code, we can create a new class based on this class that we have here. Let's say that I want to reuse this area function in a square class. Let's do that. Let's say here class square, and I can extend the rectangle class. If you have used other object-oriented languages, extends is basically inheritance here. So I can say constructor, and you know that a square has the same length for all of its sides. So I can say here side, and then I can say super side. What am I doing here? Super means that I am accessing my base class. This is the derived class and this is the base class. The square class is derived from the rectangle class. And so when I say super, I am accessing the rectangle class from the square class. And here I am invoking the constructor of the rectangle class so that I can pass the height and the width of the square, which of course is of the same length. So now I can do the following. I can save, and I can come back down here, and I can say const square 1 equal to new square, and I can pass only one value, let's say 5, and now I can say square 1 dot area. As you can see, I can use area in my square. Let me comment this out so that we don't have too many things on the console. And now let's say node classes, enter, and as you can see we have the area of the rectangle is 25. Now of course it says rectangle, but we know that a square is a kind of rectangle, which is great. So as you can see, we were able to use the area function of the base class from an instance of the derived class. In this video, we are going to study the map function of arrays. The idea is the following. An array has several values, and sometimes we want to make a transformation to each of those values and put that in another array. Let's see an example. Let's say const numbers, and we're going to write the numbers from 1 to 5, and then we're going to say const squares. I want to multiply each of these numbers by themselves. For example, 1 times 1, 2 times 2, 3 times 3, and so on, and put that in another array. We can use the map function for that. So let's say numbers.map, and in here I can take the value, I can say value, which represents the value of each individual element of the array, and say value times value. And that's actually it. With this, what I'm saying is take each of these elements and multiply them by themselves and put that in any array. Let's see that. Let's say here console log squares semicolon, and now let's go to the terminal because I want to say node array tab, enter, and as you can see we have 1, 4, 9, 16 and 25, which means that indeed we were able to multiply every value of the original array by itself and then put the result of that in a new array. Another use case of the map function is to extract a specific property from an array of objects and put those properties into another array. Let's see an example of that. Let me say here example 1 and now example 2, and I will say const people equal to array of person. I will say ID 1, name Felipe, and country DR, and I will clone these two lines twice, and I will say 2. Here I will say Scott, and here I will say USA, and here I will say 3, Jennifer, and I will say here Canada. Okay, so now let's say that from this array of people I want to extract the ID of each of the persons of the array. We can do that. We can say const IDs equal to people map, and I can just say person here, and from the person I want to extract its ID. And that's actually it. With this, IDs will be equal to an array of 1, 2, and 3. Let's see that. Let's say console log IDs, and let me comment this out, these squares from the previous example, and now let me say node array map, enter, 1, 2, and 3, as you can see, which are the values of each ID property of each person. Another thing that we can do is to generate HTML from a JavaScript array. For example, let's say example 3, and let's do this here. Let's say const diffs equal to numbers.map. I will use my numbers array for this example, and I will say here number, and I want to do the following. I want to say backtick. I will say div here and div here, and inside of a div I want to put the value, which is number. Now I will have several divs, one for each number of my numbers array. Let me comment this out because I want to console log our divs variable. So let's say divs here, and now let me clean this out and say node array map. And as you can see, we have several HTML elements here as an array, which then can be put in a web application or something like that. This is actually really useful for libraries like React, in which we do operations like this all the time. In this video, we are going to discuss asynchronous programming in JavaScript. The idea is the following. Sometimes you want to execute a piece of functionality that resides outside of your application. Like for example, when you consume a web service, the web service is outside of your JavaScript application. So meanwhile, that web service is processing your request, your application should not come to a halt, should not just stop. Your application should do other things. Meanwhile, the web service is processing the request. And then when the web service finishes and sends a response to your application, then your application should stop whatever it's doing and process the response of the web service. That is basically the gist of asynchronous programming. Your application can do something while it's waiting for something else outside of the application to finish. There are ways to do asynchronous programming by waiting asynchronously for something to happen inside of your application, but that is outside of the scope of this video. So let's see an example. Let's say that I want to consume a web service from a JavaScript code. Here we are in an HTML file. As you can see, there is basically nothing in it. So let me say function consume web service, and I will say here fetch. I will use what's called the fetch API. With the fetch API, I can make HTTP requests from my JavaScript application in a browser into another web service or web server. I will paste the following URL, which is used for making examples that consume web services. Now, as we just said, we are going to make an HTTP request to this web service. While this operation is being taken care of, our application should not stop. But how does my JavaScript application know that this will not return immediately? Well, because of the promise response that you can see on a screen. A promise in JavaScript represents a value that will be fulfilled in the future. So then JavaScript knows that this fetch operation may not finish quickly, and therefore it should just not wait for it. The application should not stop working just because it is waiting for the fetch operation to finish. It should instead do other things so that the application doesn't freeze. Now, how do we indicate that we want to do something after the web service responds to our application? For that, we can say .then. Then allows me to pass a function that will be executed once the fetch operation finishes successfully. And notice that I said successfully because we're going to learn how to deal with errors in just a moment. But first, I want to say here, response, I want to pass a lambda function or an arrow function into this then so that I can say, for example, response JSON. What am I doing here? I am taking whatever response I am getting from this fetch operation, and then I am applying the JSON function to that response so that we are transforming the response into JSON. Now, if you see here, JSON also returns a promise, and therefore this is also a asynchronous function, which means that we can say here then one more time, and here we are getting a JSON, and I can just console log that JSON or do whatever I want with it. So what are we doing here? We are saying fetch please, which means make an HTTP request into this URL, and then in the future you are going to get a response, and when you get that response, I want you to invoke this function that I am passing you here, and what that function is doing is taking that response and executing a JSON function, which itself is also an asynchronous function, which means that we can use then one more time so that when that function finishes, we are going to execute this function that we have here. And what we are getting is a JSON representation of the response of this HTTP request that we did here, of the body of the HTTP response of the request that we just made, and then we are console logging that. Let's see that. Let me come here and say consume web service, and I want to right click here and use open with live server, which comes from an extension that we installed in the past, which is extensions live, which is this extension that we have here. Just in case you forgot to install it, here it is. Now let me go back here, right click, open with live server, and as you can see we have our page here. If I press F12, you are going to see that we have an object, and this object has some information, and that information is what comes from the web service. Now, something that I told you before is that we were going to see how to handle errors, because then is only invoked when the operation was successful. But what if I made a mistake and I changed this to X, for example, HTTP X? Let me save and let's come back here, and you're going to see that we got an exception, of course. But what if I don't want this? What if I want to do something in case of an exception, something special? I can come back here, and after this then I can say .catch. Catch means that this will be executed in the case there is an error with the promise. Remember that fetch returns a promise, and if there is an error with the operation, then this catch will be executed. And here I can say error, and I will just say alert, something bad just happened, and we're sad about it. And that's fine. Let me save, and let's come back here, and you're going to see that we get the message displayed here. And of course, if we fix the error, HTTPS, save, and come back here, you are going to see that we only get the JSON log in the console and not the alert here, because catch only runs when there is an error. Now, this is all good and fine, but it can be a little bit difficult. for some people to read this, fetch, then catch, then. There is a better way, at least better in my opinion, of course. If you prefer this, then you can definitely go for it. But you can use something called async await to simplify the way we deal with asynchronous programming. Let's see an example. I will say async here, function consume web service async. So this is a new function, and this will do exactly the same that we did here, but without using then and catch, and just using async. When I mark a function as async, it means that I will use asynchronous programming with it, but the idea of marking it as async is to be able to use the await operator. Let's use the await operator, and I will explain you what it is. I will say here const response equal to, and I will just copy this fetch from here and paste it here, semicolon here, and say here await. What is this await about? Await allows me to indicate to JavaScript that this is an asynchronous operation, right? So I only want to continue the execution of this function when this asynchronous operation finishes. So this await means asynchronously waiting for the fulfilling of this fetch request. And then I can say here const JSON await response.json, because remember that this JSON function returns a promise and we have to await the promise in order to continue with the execution of this function. And then after that I can say console log JSON, which is this variable that we have here. So as you can see, this function is exactly the same as this one except for the catch, which we are going to solve in just a minute, but they do exactly the same. But with async and await, we can program in a way that feels like it is synchronous programming, but because we are using the await operator, then we are asynchronously waiting for the execution of this asynchronous operation, this fetch that we have here, and the same for this await response JSON that we have here. Now I told you that we were going to include the catch here, so for that we have to say try. We're going to do a try catch. A try catch allows me to execute some custom functionality in the case of an exception. So I will say here catch X here, and in here I will do the same thing I did here. I will just copy this alert and I will paste it here. And again, these two functions do exactly the same thing. The only difference is the style in which they do it. This one uses then and catch, and this other one uses async await. Let's test this one. Let's test this. I will comment this out and I will put here consume web service async, and I will come back to Chrome, and as you can see everything is working. And if I change this to X and I will save and I'll come back here, you are going to see that we once again have the same alert, which means that indeed these two functions are exactly equivalent. The only difference is that one uses then and catch and the other uses await. But it is on you which one you prefer to use. I personally prefer this one because it feels easier to read, but the choice is yours. Rarely, our JavaScript applications consist of a single file. In the past, in this module, we have always been using a single file for our examples, but in real life, your applications will consist of several files. So I wanted to make an example of that. And to make things easier for us, we are going to come to codesandbox.io and we are going to click on Create Sandbox, and we will select Vanilla JavaScript, which will allow us to have a little environment in which we will be able to use modules easily. What is a module? With a module, we can organize our application in different sections. That way we can encapsulate classes, variables, functions in their respective section or module, and then import those elements from those modules from other modules. For example, here we are in our index.js file. And as you can see, I am importing styles.css, and that is fine, but what if we want to create a module that will contain a person? Remember that in the past we have been using a person object. What if I want to have that in another place and import that from here? Let's do that. I will go to src, right click, create file, and I will say person.js, enter. And in person.js I will do the following. I will say const first name equal to Felipe. I will also say const age equal to 999, and also a function const duplicate equal to value times 2. These are just example values which are going to allow us to understand how to use modules. Now I want to use this first name from my index.js file. How do I do that? Well, first I have to export it. By default, none of this is accessible from outside of this file. I have to say here export, for example, first name. Now I am exporting first name, which means that it is accessible from outside of this module. I can come here and say import first name from, and I can say ./person. And now I can come here and I can use it. For example, I can delete this and just say here first name. And as you can see here we have Felipe. So from index.js I am being able to import this value that I have here. But I am not limited to only exporting a single value. I can also export age and duplicate. Let's do that. I can say age here and duplicate here, and now I can save, and from here I can come here and say I want to import age and also the duplicate function. And now I can say here, let's say age, and as you can see we have 999, and also I can say here duplicate 2, and we have here 4, which is great. Now if I come here and I stop exporting age, for example, then we are getting undefined here. Why is that? Because we are trying to import something that is not exported from the module, and we are not allowed to do that, and therefore age is undefined. Something else that you will see when you work with modules are default exports. For example, let's say that I want to make this as the default export element from this module. For that I can say here as default, and I can come here, and now you will see that we haven't defined here. Why is that? Because this syntax in which we are importing and using a curly bracket is used for things that are not default. I have to take this out from here and say, for example, first name, comma, like this, and now I have first name, Felipe, undefined for age. Let me delete age from here and also from here. But besides that, everything is working. I have first name here outside of the curly bracket because this is the default export from our person module. And I don't have to name it first name. I can name it whatever I want. For example, I can say here my value and put here my value, and you are going to see that my value is equal to Felipe. It doesn't matter because since there is only one default value to export, JavaScript knows that this my value represents the thing that is being exported by default. We can do the same for things that are not the default export. For example, I can create an alias here. Let's say as duplicate2, and let me put this in another line so that it can be better visualized. And now I have to say here duplicate2 in order for this to work. So as you can see, we can also use aliases when we are importing something from another module. Now, something else that you will see is that you can omit this and do the exporting from here. I can say export const first name, export const age, export const duplicate, and now I can come back here and I can delete this, and now I will say first name as my value, duplicate as duplicate2. I am creating aliases here, which are optional of course, but as you can see, now everything is working. And this is great. It means that you have different styles for exporting elements from your modules. In my case, I tend to use this the most because it's easier to see. And of course, it goes without saying that you cannot export whatever you just don't want to export. Like if I don't want to export this age value, then I just don't do it. And now it will be impossible for another module to get the value of age. The same can be said for classes, functions, and things like that you want to encapsulate in your modules and you don't want other modules to be able to use them. So in our real applications, we are always going to be using modules because in that way we can organize our code more efficiently. We saw that with let we can declare variables at the code block level and we can update those variables, whereas with const we declare constants that cannot be reassigned. With arrow functions we have a shorthand syntax for declaring functions. We also saw that the this of an arrow function refers to the environment where the function was declared. With template strings, we can use backticks to define strings that occupy several lines, and that also allows us to perform string interpolation, which is when we can use templates to insert values into a string. With the ternary operator, we have an abbreviated form of an if-else where we can evaluate an expression depending on the value of a boolean. We use this to assign a value to a variable depending on the value of the boolean. With destructuring, we can extract values from objects and arrays in a simple way and assign them to variables. With the spread operator, we can extract the values of objects and arrays and use them in different manners, like for concatenating arrays, cloning objects, and so on. With classes, we can create code units that encapsulate data and functionality. Array map allows us to map the values of an array to another array while transforming set values. Promises represent operations that will be fulfilled in the future and allows us to do other stuff with our application while those operations are finished. Async await allows us to use a nicer syntax to work with asynchronous programming. Modules allows us to isolate data and functionality in one place so that we can share what we want from these elements and import them into other modules at will.